Hello everyone, welcome to my YouTube channel. I am Payal of first semester pursuing my computer science and engineering specialization in cyber security degree from Sri Venkateswara College of Engineering, and today we will discuss about corrosion. So basically corrosion are of two types. First, dry corrosion and the other one is wet corrosion. First, we will discuss about corrosion. So, corrosion is an electrochemical or chemical process in which destruction or deterioration or loss of metal or alloy surfaces takes place in presence of air or moisture. For example, rusting of iron, that is a reddish brown scale formation on iron objects, or we can take other example like green scale formed on copper vessels. Corrosion may occur in dry environment or in aqueous medium. The former one is called dry corrosion and the latter is called wet corrosion. Dry corrosion. Dry corrosion is also called chemical corrosion. In this, dry gases directly attacks on metals mainly through chemical reactions. It involves direct attack of atmospheric gases such as oxygen, hydrogen, sulfide, halogen, and sulfur dioxide on metal, forming the layer of oxide. For example, the attack of dry air or oxygen on the metal, forming the oxide layer on the surface of metal. Wet corrosion. Wet corrosion is also called electrochemical corrosion. It involves reaction in aqueous medium. In this, the conducting surface of metal undergoes electrochemical reaction with moisture and oxygen present in atmosphere. For example, rusting of iron. Corrosion are of four types: differential metal corrosion, differential aeration corrosion, waterline corrosion, and pitting corrosion. Differential metal corrosion. It occurs when two dissimilar metals are in contact with each other and exposed to a corrosive conducting medium. In this, the metal with lower electrode potential acts as anode, undergo oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode, undergo reduction and remains unaffected from corrosion. This type of corrosion is also called galvanic corrosion. The rate of corrosion depends mainly on the difference in potential between two metals. Higher the difference, faster is the rate of corrosion. For example, tin coating copper vessels, steel pipe connecting to copper plumbing, bolt and nut made of different metals. Differential aeration corrosion. It occurs when a metal is exposed to different concentration of air or oxygen. Then part of the metal exposed to lower concentration of oxygen becomes anodic and undergoes oxidation and gets corroded, whereas other part of the metal exposed to higher concentration of oxygen becomes cathodic and undergoes reduction and remains unaffected from corrosion. This kind of corrosion is called differential aeration corrosion. There are some examples which shows differential aeration corrosion, like iron rod partially immersed in NaCl solution or part of the nail inside the wall undergoes corrosion, or when a dust particle sits on a metal bar, the part under the dust undergoes corrosion, or partially filled iron tap undergo corrosion inside the water. Waterline corrosion. It is observed in steel or iron water tanks partially filled with water. When a steel tank is partially filled with water for a long time, then the inner portion of the tank below the waterline is exposed only to dissolved oxygen, whereas the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes oxygen and gets corroded, whereas the upper portion acts as cathode and undergoes reduction and remains unaffected from corrosion. A distinct brown line is formed just below the waterline is due to the deposition of rust. Another example of waterline corrosion is ships which remains partially immersed in sea for a long time undergoes waterline corrosion. Pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion mainly occurs due to four reasons. First, when metal surface is not homogeneous. Second, when external environment is not homogeneous. Third, when crystallography directions are not equal in the reactivity or when environment are not uniform with respect to concentration. Pitting corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergoes oxidation and gets corroded and forms pit, whereas the remaining area of the metal which is exposed to higher concentration of oxygen becomes cathodic and undergoes reduction and remains unaffected from corrosion. Once a small pit is formed, the rate of corrosion increases because of formation of small anodic area, that is pit, to corrode faster because accepting electrons from the cathodic area increases. This is the pictorial representation showing pitting corrosion. Thank you.